Welcome to today's video where we take balancing reactions up another level. And as you are going to see, balancing reaction is quite simple. And as we always say, there is no hard and fast route to actually balancing chemical reactions. There are some pretty principles you can have that you have to keep at the back of your mind. However, there are some cases you get to where those principles do not exactly work. So you just have to use some ideas and some thought processes just to make sure you get it all. And you're going to be seeing some of those examples. However, what I just did is, let's have one which is quite simple, and we can do that in just say a few minutes. So you don't have to wait for me for this one. If you can do it for the very first example, just take it out. Pause the video, see if you can get the answer. And if you can, wonderful. Move on to the next one. However, as you're going to see, like I've already said, these things work on principles, but there's no hard and fast routes per se to balancing chemical reactions. So we are going to be seeing each of these things in play with the examples you are going to be seeing. So kindly watch to the end and see more examples, which I believe after this, you are going to be very, very fantastic when it comes to balancing chemical reactions. And if you do find this video helpful, always remember to like, share, and to subscribe. First, what we have here is the reaction between iron and chlorine to form iron chloride, or some will say iron 3 chloride. So let's just balance it. Remember, we count how many atoms. We have 1 iron. We have 2 chlorine on the reactant side. On the product side, we have 1 iron. And we have 3 chlorines. So obviously, the iron is balanced. All that's left is to balance the chlorine. Now, if you observe, 2 and 3, 2 is an even number and 3 is an odd number. So there is no way to make 2 become 3. Well, there is a way you can do it using the fraction method, but we are not using that for this video. What we are going to do here is, one, I also like to teach people. All you basically have to do is, since 2 is an even number and 3 is an odd number, you basically just use both numbers to multiply each other. And that gives you exactly what you need. So what I mean is, I take 2, multiply by 3, and I take 3, multiply by 2. So you multiply it with themselves to give you something, and it just becomes even, and it makes your work much more easier. So now you're going to have 2 times 3 is 6, 3 times 2 is 6. So you just how you do it. So you watch it now. Chlorine on the reactant side was multiplied by 3, so you place a 3 here. Chlorine on the product side was multiplied by 2, so you place a 2 here. Now you always remember the principle of balancing chemical reactions. You must make sure you recount after every step. And if you do recount, you are going to find out that your iron here is still 1. Chlorine here is now 6, which is balanced, with the chlorine here, which is also 6. 2 times 3 is 6. But your iron is no longer 1, it is now 2. So to make iron become 2, simply multiply by 2 also. So you get 2. And you place your 2 here. So that's a simple trick that I normally tell people to use. Just multiply them. This one is even and the other one is odd. It's either use the fraction method, which will work in this case, or you just use both numbers to multiply themselves and balance the other atoms that are affected. And also, to save your time when balancing chemical reactions, always remember, you only need to recount the side that was affected. So you don't need to go and count everything again. So in this case, now you need to do was count chlorine and count the part for iron chloride. No need to come and count iron again because it was not affected at the very beginning. Alright, so that was just a simple example for us to show our mouths with. Let's now move on to other examples, which will involve adjustments and possible readjustments. So let's see. Again, we count. Potassium is just 1. Manganese is 1. Oxygen is 4. hydrogen is 1, chlorine is 1. On the product side, potassium is 1, manganese is 1. I like counting in the same order so I don't mix things up. Oxygen, also 1. Hydrogen is 2. And then chlorine. Remember when you are counting, you count everything on a particular side. So you can see there's chlorine here, there's chlorine here, and there's chlorine here. So you count them all together on the product side. So you have 1 plus 2 plus 2, which gives a total of 5. So we have 5 atoms of chlorine on the product side. Always remember that most times students make the mistake of counting just one of the chlorines. Make sure you count everything. That's how you are balancing. Remember the principle of the law of conservation of mass. You are balancing both sides of the reaction, the reactant side and the product side. So you count everything together. Now, one principle that I always love when it comes to balancing chemical equations is that principle that says elements or atoms that appear on the same side of a chemical reaction and they appear in more than one place should be balanced last. What does that mean? You can see chlorine on the product side appears in 3 places. So we are going to balance chlorine last. It helps a lot. If you balance chlorine first, it will work, but it will affect other atoms negatively. So it is better you balance other atoms first. And in this case, chlorine that is appearing in more than one place, you balance it as the last atom. So let's go ahead and balance. Potassium is 1, 1, balanced. Manganese 1, 1, also balanced. Oxygen is 4 on the reactant side, but over on the product side, it is 1. So you make 1 become 2, multiply by 2. So we multiply the oxygen on the product side by 2. We come to where we have oxygen, and we place a 2 there. Oh, sorry, it should be multiplied by 4 actually. Oxygen is 4 on the product side. All right, so that should be 4. Now, again, remember, when recounting, only recount the atoms that you adjusted their number. No need to recount everything again. So in this case, we only adjusted water over here. Oxygen is now 4 as you have seen, but hydrogen is now 8. So it's no longer 2, it is now 8. So we come over to the reactant side. How do we make 1 become 8? Multiply by 8. So we have 8. So simply come here and we'll place an 8 there. Now, it remains chlorine. On the product side, on the reactant side, sorry, if you now count again, it is no longer 1, it is now actually 8. While on the product side, it still remains 5. So you can see again, in this point, or at this point, there is no hard and fast rule about it. You also have to be very careful. And you can see why I don't normally use the fraction method. Well, it will work in this case, in the very first case that we use. But in this case, it wouldn't work. Because now, you can't just multiply both sides and say I want to multiply 5 by 8 and multiply 8 by 5. Why? Chlorine appears in more than one place. So what exactly do we do? It means we have to go back and readjust our atoms. That's simply what you do. So the very first step I like to take is the one that is odd. I first of all make it become even. We are talking about chlorine now. So you can see there's a part of chlorine which is 1. And that is the part that's attached to potassium chloride. So I simply adjust it and place a 2 there to make it become even. 1 is odd. I make it become even. That's 2. So what do we have now? Recounting again. That means our chlorine here is no longer 1. It is now 2. So automatically here is 6. But remember, having adjusted this side, we have 2 chlorines here, but it's also affected the potassium. Potassium is now 2. That means this place becomes 2. So automatically I have to go back again and recount potassium. And so here, make it become 2, becomes 1 times 2, and that is 2. So I go to where I have potassium on the reactant side, and I place a 2 there. And you can see what has happened again now. Because I adjusted potassium, when I recount, manganese is no longer 1, manganese is now 2. Oxygen is no longer 4, oxygen is now actually 8. So I have to adjust all over again. Manganese on the reactant side is 1, on the product side to make it become 2, that's 1 times 2 becomes 2. So I go to the product side where I have manganese, I place a 2 there. Now guess what again? Remember, always recount. That is the key to balancing this. It's quite simple, but always recount. Manganese is now 2, but check out chlorine. Chlorine here is no longer 2. Chlorine now is 4. So this place becomes 2 plus 4 is 6, 4 plus 2 is 8. So you can see that chlorine is now actually balanced. But remember, in recounting, we have adjusted manganese and potassium because they were affected. Check out oxygen. Oxygen is now 8, as you have already noted. Oxygen on the product side also needs to become 8. So that means this our initial number, which is 4, can no longer work. So we have to adjust 4 to become 8. So now we have 8. And then when you recount, hydrogen is now 16. That means this no longer works. We have to come over here, and we already know that this 8 can no longer work. So we have to take out the 8. Sorry about that. Let's bring back the H. So the 8, that number of moles we added before, is no longer feasible. We have to take it out. What's now feasible? Hydrogen here is 16. 8 times 2 is 16. But here hydrogen is just 1. 1. Multiply by 16 to become 16. We had to adjust it. It was 8 before, but now it is 16. 8 times 2 is 16. So multiply by 16 becomes 16. And then again, what happens? Your chlorine, every part you adjust must be recounted. Your chlorine is no longer 8 anymore. It is now 16. So let's see. What did we have? We had 2 plus 4 plus 2, and there we had 8. So now what do we do? Now if you observe, if you begin to adjust this chlorine or this chlorine, it goes back to affect your potassium and your manganese again. And we are left with only chlorine to balance. So what do? Come and check over here. This chlorine is just standing alone. So we can easily adjust this chlorine to fill up for whatever is left. So now what happens? We have, let's assume all these ones were the past. Now we are working for the future. We have 2 chlorine here. 2 times 2 here, we have 4. That gives us 6. But we need 16. That means we have 6, but we need a balance of 10. So we can simply use this last chlorine that is standing alone to get the balance 10. So that simply means that we just need to make this chlorine become 10. And how do we do that? It is currently 2. To make it become 10, you simply multiply by 5. And now it is 10. And if you calculate all your chlorines together, you have 2. 2 times 2 is 4. 2 plus 4 is 6. 5 times 2 is 10. 10 plus 6 gives us 16, like we already have here. So you can see the key is always remember, after each balance, you must count again. And then when balancing, always try, when you have an odd number and it is not yet balanced, try to make that odd number become an even number if that atom needs to be balanced. But if it does not, there is no need adjusting that particular atom. So that is pretty the way it works. So you can see what we did. We adjusted everything else until it was left for only chlorine to make the final adjustments. And we simply came to where we had chlorine as a free atom and we made the adjustments. All right. For the next example, quite simple, isn't it? For the next example, now in this part, we also have to be pretty careful with it, although it is still straightforward. But then again, always remember the principle. The idea is always, there is no hard and fast rule to balancing chemical equations, but you just need some basic principles in mind, and then you're able to now use little methodologies to adjust as you need. So let's count again. On the reactant side, sodium is 2, chromium is 2, oxygen is 7. Now you can see another principle again. In order to avoid some stress, which are avoidable, polyatomic atoms, take them as one atom. And what do we mean by polyatomic atoms? They are atoms which appear the same on both the reactant side and the product side. An example now, you can see we have SO4, that's sulfate. It appears as SO4 on the reactant side, appears as SO4 on the product side. So we take it as a polyatomic atom. That's why we are counting it as SO4, separate from oxygen. So you can see I can see oxygen separate from sulfate. However, some people can say they want to take each other separately. You can do that, but the stress levels become a lot higher. So iron is 1, and then sulfate, we have 1 here, plus 1 here. That means we have just 2. Hydrogen is 2. On the product side, sodium is 2, chromium is 2, Cr₂, Na₂. Oxygen is 1, iron is 2, sulfate. Remember, whenever you have a bracket, the number outside the bracket affects everything inside the bracket. So SO4 here is 3, SO4 here is 3, 3 plus 3 is 6, SO4 here is 1, 6 plus 1 is 7. And then we have hydrogen here as 2. So now we begin to balance. Sodium is balanced, chromium is balanced, we balance oxygen. Again, remember, anything that appears in more than one place on the same side, it is advisable to balance it last. So you can see SO4 appears in more than one place. SO4 appears in more than one place on the product side too. So we are going to balance that as the last. All right, so we go to oxygen. Oxygen on the reactant side is 7, but on the product side it is 1. So to make 1 become 7, it's simply 1 times 7. That gives us 7. So I go to where I have oxygen on the product side, because that's where I adjusted, and I place my 7 there. So I recount everything about this water again. When I recount, oxygen is 7 as I've done, but hydrogen is now 14. So I come to my product side, hydrogen is no longer 2, it is now 14. So I go straight ahead and I adjust hydrogen. Or better yet, how can I make 2 become 14? Simply multiply by 7. 2 times 7 gives us 14. So I multiplied by 7, sorry. So I simply go to where I have hydrogen on the reactant side and place my 7 there. Going pretty well currently. Now, here's the next step. Iron is 1 on the reactant side and 2 on the product side. We can do that now, but however, let's try to be a little proactive in this case. Now let's look at it. If I make ion 2 over here, my sulfate becomes 3. Sorry, it becomes 2 here. Let's just do it for, let's say, doing sake. We have 2 here. 2 plus 7 is 9. However, how many sulfate are we going to have here? 3 plus 3, that's 6, plus 1, that's 7. So you can see that if I adjust this one, it's not going to be enough to actually balance the chemical reaction. And then again, here are the tricks that we speak about. In order to balance this chemical reaction, I have only sulfate to balance now, if I balance ion in this case. And the trick here is that you need to use this ion sulfates to balance your chemical reaction. Because you can see that here is ion sulfates and here is ion sulfate. Just, let's say, different natures. Because you know ion is a transition element, so it exhibits variable oxidation numbers. So in this case, this is ion 2 sulfates and this regular ion sulfates. But the point here is that iron and sulfate atoms are together here. Iron and sulfate atoms are together here. And sulfates needs to be balanced at the end of everything. So it is better you balance it with these ion sulfates, because for every atom you are going to attempt to use, it will go back and disrupt the whole chemical reaction. Now imagine you wanted to adjust sulfates and you want to use sodium. Once you adjust sodium on the product side, you need to come back and adjust sodium on the reactant side. And what will happen? It will affect oxygen. You have to come back and affect the oxygen on the product side. And once you affect oxygen, it comes back to affect hydrogen. You have to come back and affect again or adjust hydrogen on the reactant side. So you can see that it will be a continuous cycle if you consider that. Same thing happens to chromium. Chromium here, if you adjust the chromium here, it affects the chromium here, which is attached to sodium and oxygen. So automatically, if I adjust this chromium here, it will come back and affect this chromium over here. It will affect the oxygen as a result, affect sodium as a result, and it will also come back to affect, back on the product side, sodium sulfates and water. It will just continue like that, and it will become almost impossible to balance. So what does that mean? The secret to balancing this chemical reaction lies in ion sulfates, because they are together over here. So what do? It becomes pretty simple. Remember what we said. Using a 2 here does not balance the chemical reaction. So it's of no use to use a 2. So now remember, now we are thinking of 2 things together. We want to balance ion and we want to balance sulfates. But then again, observe, the both of them are not the same nature of numbers. 2 is even and 3 is odd. So what do they say is the solution? Use them to multiply each other to get a number that the both of them can divide. Guess I'm using a little mass inside now. So particularly what to do here is 2 times 3 is what? 6. Because if I come here, observe it again. If I use 2, it doesn't work like I already tried. If I should use 3, ion is no longer balanced and sulfate is 10. So you can say it becomes difficult because I have an even number and an odd number trying to work together to get balanced. It's not going to work. So what I do is that I take a number that the both of them can divide and use that number. And with that number, it becomes easier to balance the both of them together. So 2 times 3 is 6. That means that is a number that the both of them can work with. So I simply come here and I place a 6. So now I have 6 ions and I have sulfate. Remember, in total is going to be 13. 6 here plus the 7 from here. So 6 ions now, it becomes easier to balance this. If ion is 6, that means here is no longer 1, it's now 6. Here, I need to multiply by 3 to give 6. So I multiply by 3, I come to have ion on the product side, and I place a 3 there. So now again, remember the solution, recount. Sodium is still 2, chromium is 2, oxygen is 7, ion is 6. For our sulfates, we have this no longer 2. We have 6 from here plus 7 from here. That gives a total of 13. This definitely not be 7 anymore. We have 1 from here, plus 3 from here, plus 3 times 3. Always remember, the number of moles behind affects the subscript, which is at the bottom. 3 times 3 is 9. 1 plus 3 is 4. 4 plus 9 is 13. Hydrogen still remains 14. So you can see, those are tricks that you get to take in mind when balancing chemical reactions. What do I do? That should be your first thought. What do I do to make my work much more easier? All right. Again, we count. Lead is 3, oxygen is 4, hydrogen is 1, chlorine is 1. Lead is 1. Chlorine appears in 2 places. That's 2 plus 4, which gives 6. Hydrogen is 2, and oxygen is 1. Oh, sorry, I think I misplaced them. I placed oxygen for chlorine. Sorry, oxygen is 1, hydrogen is 2, and chlorine is 2 plus 4, which is 6. Again, remember the underlying principle. You can see those principles work, but you have to use some methodologies to know exactly when to use them and how it fits you. And what's the principle we're talking about here? Chlorine appears in 2 places on the same side, so that will be the last thing I balance. It's pretty that simple. So you can see chlorine on the product side appears in 2 places, so chlorine will be the last thing we balance. Let's leave that first. Lead appears first, but remember our principle when we were speaking about it earlier. Most times, balancing with odd numbers should be our last options. So lead being odd, we are going to hold on first. Again, in balanced chemical reactions, nothing says you must balance the first one first. You can balance any one first. These are just small tricks that you use as you move on. So this being odd, I want to make it a last resort. You saw earlier when we were balancing chlorine, when we used 5, that was our last step. So when balancing a reaction and you are having to work with odd numbers, make sure that is your last option or last step, because it's easier to work with even numbers. So I'm going to hold off on lead and do others first. Again, our lead, apologies, is not 1. It's actually 1 plus 1. That's 2. 1 here and 1 here. And then again, if you observe, lead appears in more than one place, so it should be part of what to balance last. There are times when you balance other elements, the one that appears in more than one place, they automatically balance themselves. But let's see what we can do. Alright, so we'll go with oxygen first. Oxygen here is 4. On the product side is 1, so make it become 4. That's 1 times 4, which is 4. So I come to have oxygen on the product side and place a 4 there. When you recount, hydrogen is no longer 2, it is now 8. Always remember your shortcuts. It is only the element that you adjusted that you need to recount, or the compound you adjusted that you need to recount. So therefore, hydrogen here multiplied by 8. So I come to have hydrogen on the reactant side and I place 8 there. So what do you observe? Chlorine is no longer 1. Recount whatever you adjusted. Chlorine is no longer 1. It is now 8. So I balanced others. I'm left with lead and chlorine. Again, like I said, the ones that involve odd numbers, I will make it a last resort. So these two involves even numbers. Let's work with them first. 8 and 6. So what do we do? Luckily for us, chlorine appears in 2 places. 1 is already 4. So if I come here and I adjust it with a 2, 2 times 4 is already 8, greater than what we need. So what do? I adjust the part that has a lower figure, and this part has chlorine as 2. So I adjust this chlorine over here with a 2. You can see it now. We needed 8. So if I take out 4, it's remaining 4. So how does this 2 become 4? It is simply 2 times 2. You get your what you want. So here is now 8. And then check out our lead. It has now balanced itself. Why? The lead here is no longer 1, it is now 2. Lead here remains 1. 2 plus 1 now is 3. So that's simply how you do it. Tips and tricks. Alright, so we've gone over the tricky ones. Once again, let's work with something a bit simple. And in this case, we'll be doing these things. I always like doing them because they make it so clear. Whatever is happening inside here is so clear in this place. So I always really like writing them out. But as you become a better expert in these cases, you don't need them anymore. So let's see. It says provide a balanced chemical equation for the complete combustion of octane. Now, octane, let's get what we need. Octane is an hydrocarbon from the alkane series. And the alkane series is Cn, their general formula is CnH2n plus 2. So I'm assuming you're in an exam and you're not given the chemical formula. In fact, this is an exam question. I just scooped it up from there. So this is how you derive your answers. Your question first before your answers. Octane comes from the alkane series and their general formula is CnH2n plus 2. And you already know from the word oct, that means 8. Like we have octagon, nonagon, decagon, and so on. So even if you don't know organic chemistry yet, oct from irregular mathematics means 8. So that means our N is basically 8. So we have C8H, 2 times 8 is 16 plus 2. So therefore we have C8H18. So we have our first part, C8H18. What is it reacting with? They said complete combustion. You must also note, once you hear the word combustion, it means that it is reacting with oxygen. It is just that simple. And you always remember that oxygen must always be diatomic. So it must be O2. You can't have oxygen as O when it is standing alone as a free element. It's always diatomic. As we go further with further videos, you are going to be understanding all these things and knowing the main diatomic elements. They are mostly 7 in number. Alright, and then the next key again, when it comes to combustion, again, combustion means burning. When it comes to combustion of hydrocarbons, there are 2 types. We have complete and we have incomplete. Complete means it is completely burnt. Incomplete means it is not completely burnt, as the name already says. Now, when it's complete, you produce carbon dioxide. When it's incomplete, you produce carbon monoxide. It's always constant that water must be produced. So what and water? That's the only question. If it's incomplete, that will be carbon monoxide and water. But if it's complete, that's carbon dioxide and water. In our case, it says complete combustion. So it is not carbon monoxide, it is carbon dioxide. And here we go. We have our chemical equation. So now all that's left, let's provide a balanced equation as they said. Like I said, let's leave this as our derivative. You call these skeletal equations. When it's not yet balanced, you just call it a skeletal equation because it's just showing you the reacting elements, but it's not telling you what went on inside the reaction actually. Well, at least you have ideas of what happened in the reaction. That's why it's called skeletal. But when it's balanced, that is your actual proper equation. So we have C8H18 plus O2 gives us CO2 plus H2O. Like we already said, oxygen, you can see it appears in more than one place on the same side. So that will be the last thing we balance. So we can start with anything we want to start with. Like I said earlier, there is nothing that says you must start with carbon, nothing says you must start with hydrogen. Pick what is best for you and work it out. So in this case, you can see here carbon is 8, here carbon is 1. So how do I make 8 become 1? It is simply 8 times 1. So I place an 8 here. Carbon is balanced. I'm not going to recount oxygen yet, but if you want to recount, you have to note now that oxygen here alone is now 16. Then let's balance hydrogen. Oxygen must be the last. Hydrogen on the reactant side is 18. Over here is just 2. How do I make 2 become 18? Multiply by 9. So I make a 9 here. What do I have? 9 oxygens. So what does that mean? 16 plus 9 is 25. Now you can see, I cannot come here and place 25. If I place 25 there, that means I'm saying I now have 50 oxygens. And that doesn't work like that. So you can see again, we are operating with even and odd numbers. So what do? It becomes pretty simple. You just remember what brought about the odd number. Like I said, it is easier to work with even numbers. What brought about the odd number? It is this 9 that we have here. So what can I do? I can simply avoid using this 9. How do I do that? Well, you can make 9 become even. And it makes your work a lot more easier. So for that, I'm going to rewrite the equation again and see how it goes. Again, tips and tricks on how you work these things out. So watch this video over and over again and get little tricks that you use when balancing chemical equations. It is just, let's not put the 8 yet. It is quite simple once you just see your tips and tricks and combine them with the few rules that you normally have. So now let's go over it again. I have 25, but to make 2 become 25, except I'm going to use 12.5. That also works. But we are not using fractions here. And I don't think most exams will allow that. So what exactly do we do? Again, you can use fraction method here, but let's not use that. Let's go ahead and see what we can do. So now I realize that, 16 and plus 9 gave me 25, and I had an odd number. That's where the issue is coming from. Now, where did that odd number come from? It is coming from this 9. So how can I avoid using this 9? Well, this 9 came because of hydrogen. That was 18. And hydrogen was already 2. 2 divided 18 gave me 9. That's why I had to adjust here by 9. So what if this hydrogen is no longer 18? That means if this hydrogen becomes larger than 18, if I increase it, I will no longer need to use 9. But remember, you cannot change the subscript. You can only change the number behind. So I place a 2 here. Now see how it comes to life. Carbon is now 16. That means I come here and I place a 16. Then now my oxygen is now 16 times 2. That's 32. Now my hydrogen is now 36. How can I make 2 become 36? It is simply multiply by 18. So hydrogen is now 36. You can see I no longer have that odd number to work with. So now I have 32. 18 times 1 is 18. 32 plus 18, that gives me 50. Now you can see that 50 is an even number, that I can easily come here and adjust. So how can I make 2 become 50? It is simply by placing 25. And just like that, the reaction is actually balanced. Like I said, you can use the fractional method, where you come here and place 25 over 2. Then once you multiply through, you clear your fraction. Once you multiply through by 2, here becomes 2. When you multiply it by 2, it's remaining not just 25. 2 times 8 is 16. 2 times 9 is 18. You can also do that. So it all depends on which one you like best. So that is it. Try more chemical equations, and possibly the one I'll give you here is, how about you work out a balanced chemical equation for the incomplete combustion of octane? Remember, we already said it. When it's incomplete combustion, there is a particular product. So get that and let us see. If you have questions, you can always provide them and we'll work on them. But in the meantime, always remember, like, share, and subscribe.